this first lecture off with just some basic proportions of the human body. This is going to be relatively simple. This is the lightest day that we're going to have. So after this brief lecture here, I'm going to do a demonstration on how to do a Bridgman drawing, sort of a simplified version. Now keep in mind the person who executed the highest ranking Bard plate last term gets all the demonstrations and anatomy drawings from this term. So I will take their book and execute the demonstration in that book, or a different sheet of paper if they want. And then next week, after the second lecture, we're going to do Vanderpool demonstration. Then you're going to get to learn the white chalk on toned paper technique. So we'll start you off really easy this week and get the proportions out of the way, get some basic lengths of arms or bones out of the way, so that when we're constructing a figure, we can make sure things don't get too out of hand. On top of that, with the light of this knowledge here, we're going to execute some drawings in our our CDC 202 class, where we have the model come in. The model's going to take various different poses, and we're going to have to take these proportions that we're going to talk about today and draw three different cubes representing a head, a chest, and a pelvis in different perspectives. So that three-point perspective lecture that we had on Tuesday, we're going to have to utilize that in combination with knowledge here of what size these boxes should be. So that's the game plan for today. Your Bridgman book will have this information, of course, but we're going to talk about it in here, hopefully illustrate it a little more understandably for you before I set you off on your own to copy the book. Bridgman talks about how there's three main masses of the body, and each limb is built off of the main masses. And if you can get the main masses in there in the correct perspective, then that tackles a huge portion of drawing a good figure, because the limbs can be added in lots of different ways and still make sense, but your main masses have to be pretty solid before we can build on them. So we'll talk about some proportions here. Like I mentioned earlier, the proportions are going to be the head, or in this case the skull. Second is going to be the rib cage, and third is going to be the pelvis. We're going to talk about some very standardized, simplified sizes or dimensions of these, just very, very average. And of course, people will vary from here, but we want to get relatively correct. And if nothing else, get the relative proportional relationship of each of these masses to be correct. So let's go ahead and first start talking about the head. For each of these, we're going to talk about the height. Get the height in here. We're going to get the width, and we're going to get the depth, meaning how far back it goes. So we need the height, the width, and then the depth. So when looking at a basic skull, straight on, a basic skull, if you may actually already know, is about 8 inches high. 8 inches high for a typical human head, and then of course hair is going to be additional on top of that. The width for a human head should be actually about 6 inches. And of course, hair would be extra. So the key thing to take away from this, a skull that's 8 inches high and 6 inches wide, is that we're looking for a ratio of about 3 to 4, 3 wide to 4 tall, when we're executing a drawing. If a person is sitting in for a portrait and looking straight at you, we should be seeing a relationship of about 3 to 4 plus hair on top of that. If things start to get a little wonky, then we may run into some issues. For example, if the person's head is turned in this way, it starts to get 3/4, well, obviously that width becomes more narrow. It should become something like maybe 5 inches or 4 inches, depending on how the person is turning. Well, the problem with subtle turns, if something just a little bit turned like this, it would reduce it to about 5 inches. But when a lot of beginners or people new to this, students, are drawing a portrait, they almost always tend to levitate the features towards being straight on, right in the middle of the face, regardless of the subtle turn that they see. So what happens is they get the width correct of a 5-inch wide head, but they accidentally shift the features to be squared away as though the person is staring straight at them, and thus they get a very narrow, tall head, and their proportions become a bit messed up and skewed. So if we see any deviation from this, it has to be indicative of some sort of turn or tilt. Again, for example, the height, if somebody's head is looking down or looking up, then we would expect that height to be considerably shrunk. You know, a head looking, staring up like this, for example, all of a sudden the face should take on a more square appearance. So we should see something like a 1-to-1 ratio as opposed to a 3-to-4 ratio. So keep in mind, 8 inches tall, 6 inches wide, we're really looking at a ratio of about 3 to 4 straight on. As far as the depth goes, it's quite interesting. The depth from front to back is almost the same as the height. It's actually about 7.5 inches deep. And then when we add on some hair, of course, we end up seeing something that almost becomes straight on, 1-to-1 ratio as well. The next movable mass that we're going to discuss is the rib cage. And of course this will vary again by the size of the person, but we can look at some standard averages. As far as the height, how far might you guess it is? Top of the ribs being right up here, this little top guy here. Bottom of the ribs being right all the way actually down here. These are called floating ribs in the back. So from the top here to the bottom here, if we compare it to the size of a head, which is 8 inches tall, you'll find that it's about 1.5 heads tall, or 12 inches tall. That's our magic ratio for the ribs. Rib cage is 12 inches tall. The width, as you can see, is almost square when you look at the ribs down to here, which is called these are the false ribs here. From here to here and here to here, it's almost square. Although, remember, the rib cage goes all the way down to these floating guys in the back. So it's almost a 1-to-1 ratio, but not quite. So our width of our rib cage is roughly 10 inches. The depth can become a little more ambiguous. And we have to keep in mind, too, that for most people, the ribs should not be very straight up like this. This indicates some level of slouching. And in fact, a rib cage of somebody with good posture is actually leaning sort of back a bit. If we were to see this rib cage from the side, we'd see it something more like this. Well, maybe not quite that much, but like this. And in fact, that's how Bridgman's going to draw it in the textbook. So you're going to see something like this for the rib cage. And then the pelvis down here, and the head here. And this gives us that curvature of the spine. So when we talk about the depth of the ribs, we're not necessarily talking about this depth here of the actual width, like that. We're talking more about the depth from front here to back, like that. In which case, we're looking at something that's close to 1 head height, or 8 inches. So our rib cage should be about 8 inches deep. The last little movable mass we're going to talk about here is the pelvis. Now, we have to keep in mind a few things, that while men and women pelvises do vary a little bit, overall, again, proportion is going to be about the same in relation to the rest of these. And in fact, the idea that a woman's hips are much wider is often largely to do with how broad a man's shoulders appear, which thus makes the hips seem a little bit narrower. Now, women's hips are a little bit wider, but they're not as substantially wider as most people tend to think. So we can safely say that an average for men and women is that we're looking at a width of our pelvis about the same as the rib cage, which is going to be 10 inches wide. Now again, a woman's pelvis might be a little bit wider, but overall it's going to be pretty close to our standard here. As far as the height of the pelvis, and on the figure or on a model, and even on yourself, you can feel the top of your pelvis right here. This bony projection here. From the top of the pelvis down to the bottom of the pelvis, we're looking at a height that is equivalent, again, to the head height. So we have 8 inches tall for the pelvis. Notice 8 inches seems to be our magic number for a few of these measurements. The head is 8 inches tall, a pelvis is 8 inches tall, a rib cage is 8 inches deep. So that'll give you at least a basic starting, and then we can start to build all the rest of our measurements from there. As far as the depth of the pelvis, we have to keep in mind again that the pelvis is going to be a little bit angled as well. And from the back to the front, we're looking at something about 6 inches deep. So our pelvis should be about 6 inches deep. The more we commit these to memory, or these ratios at least to memory, the stronger the proportions of our figure are going to be. And that when we start to draw something, it might stand out that perhaps our pelvis is too high, a common thing, and that the pelvis and the rib cage can't possibly add up to the height they need to be. Write these all down. Do the drawings in the Bridgman book. The drawings in the Bridgman book are essentially giving you some rectangles, and you're filling in the skull, the rib cage, and the pelvis, and then you're writing down dimensions from a few different angles. Do them enough to start to commit them to memory. Keep in mind also one other thing, when you're if you were to construct a figure from this idea of proportions as well, you can keep in mind that it's about 3 inches or so, 2.5, 3 inches from the bottom of the skull down to the top of the ribs. And then from the bottom of the ribs down to the pelvis, we're looking at something along the lines of 3 to 4 inches. So that'll give you some spacing there to work with to be able to accurately construct a figure. For example, when we're doing our box drawings on after this lecture, we've got a head here, so we get something like a 3 to 4 ratio, and then maybe a rib cage here, 10 inches wide, 12 inches long, something like that. And then the pelvis here, again, it's going to be 8 inches tall. So same as the head, same width as the rib cage. And we want to kind of space these so that they look like the believable masses of the skeleton. And then we'll also put them into perspective as well. So sometimes you'll have the head bent back far enough where it's disappearing behind the rib cage, in which there would be no space. So if a figure is standing straight, we would expect to see about this much spacing between the two. And then we compensate for if the ribs are tilted and the pelvis is tilted and the head is tilted as well. So we're not just going to have a figure standing up here like a soldier. We're going to have a figure doing all sorts of these crazy poses. So it's a good idea to have an understanding of the spacing between the boxes as well. So again, we're going to say something along the lines of 3 inches up here and 4 inches down here when seen from straight on. Next, we'll tackle the lengths of the major bones. And then we'll end with some anatomical terms that we'll introduce to you this week as well, that we can use throughout the lecture course here. So, our major bones of the body. We already talked about the major masses of the body, the skull, rib cage, pelvis, and then we have some bones as well, some big bones. And when we talk about those bones, we'll just relate them to the size of the head. You know, a common way to create a figure drawing that most people instruct is to use head measurements all the way down the figure. Well, again, I mentioned I don't recommend that because a figure being 7.5 heads tall, those 7.5 measurements can add up to, those little mistakes can add up to large mistakes over the course of the whole figure. So we're going to just compare our head to lengths of the arm. So for example, if we have a figure seated at the side like this and the head straight on, we could say take the unit of as a head unit measurement and compare it to the leg and make sure that our femur is not too long or too short, which is a common thing that we sometimes see. So let's start running down the list here. We start with this guy up here, this first arm bone right at top. It's called the humerus. And the length of the humerus relative to the head is about 1.5 heads tall. So your upper arm should be from about here down to the elbow, 1.5 heads. The forearm bones beyond that are actually going to be a little bit closer, you can see, to one head or just over one head. About, at most, probably 1.25 heads long. So this is going to be the radius and the ulna. We'll talk specifically about them in the week we handle the arm. But the radius and ulna, the bones of your forearm, are about one head, up to 1.25. So that covers our arms. Moving down to our legs, we have the first one here, the thigh bone, the longest, strongest bone in the body here. This is the femur. Nice, long, strong bone, femur. If we compare the femur to the size of the head, we're looking at something like 2 heads. So femur, your leg from this bony projection on your hips here, which is the greater trochanter, all the way down to your knee, it's going to be about 2 heads. Last but not least, we have bones of the lower leg here. So here we're looking from the knee down to the foot. And this measurement is going to be similar to our humerus, actually, about 1.5 heads long. So the bone we're giving that length to is the tibia and the fibula. The tibia is the front bone, the shin bone. And we'll talk more about it on the week with the leg. So you can actually feel that bone, the tibia, running all along the front of your lower leg. 1.5 heads. So to recap, humerus, 1.5 heads. Radius and ulna, about 1 head, a little over 1 head. Femur, 2 heads. And then tibia, 1.5 heads. Make sure that as we're doing our drawings and constructing our boxes and schemes and envelopes and shadow mapping of the figure, that we conform to about these standards, of course taking into account any perspective we might see. So again, you'll never see these bones longer proportionally to the head than that. But if they're angled more towards you, they may appear shorter. So we have to take all of that into account. Last but not least, we're going to look at some navigational terms of the body. So this is going to it's going to help us to point out which side of the body we're looking to or how far away from the body that we're looking to. So when we say, the arm, or we say the humerus, for example, we know which end of the humerus we're looking at and which side of the humerus we're looking at as well. So we have to get a grip on these fairly early on We'll use them throughout the entire term this term, throughout the entire term next term, and probably into painting as well. When we start doing the figure, we're going to utilize these terms also. So it's a good idea to have an understanding, so we don't just say something like the right side of that arm. Well, which right? Our right, the model's right, which end? The close end, the far end? What does that mean? So these are going to be very specific terms that will help us pinpoint exactly where it is we're talking about. First we'll look at, let's see, medial and lateral. Medial and lateral. Keep in mind, these terms are always going to come in pairs, so there will always be one side and another side, and it's always point of reference, so you can't have one without the other. And in this case, medial is going to refer to the midline of the body. So if we have our figure here, medial refers to the center line. So I would say something like the medial side of the arm is going to be this side of the arm because it's closer to the midline of the body. Or if I say, you know, the sternum is medial, or say something like, oh gosh, maybe the obliques are medial to the arm. They're more toward the midline. The opposite of that would be lateral. Lateral is going to be away from the midline, so towards the outside. So I would say, if I were talking about the lateral side of the humerus, I would be talking about the outside of the humerus. The medial side of the humerus would be the inside of the humerus. So lateral, medial. Lateral side of the ribs, medial side of the ribs. Lateral, medial. So we'll write midline to the body for medial, and outside remember, we want to also include this conditional statement as toward. So toward the midline of the body, toward the outside of the body. So that's our first set, medial, lateral. Next we'll look at proximal and distal. Basic reasoning would tell us that proximal is closer in proximity, distal is further away or more distant. But to what? That's the question. Without having the to what, we don't know exactly what something is closer to or further away from. So when we refer to proximal and distal, we're going to be referring to the trunk of the body here, toward where an appendage attaches toward the body. So in the case of the arms, you know, right here by the armpits. The legs is going to be right at the pelvis. So I would use a phrase to say something like the hand is distal to the elbow, meaning the hand is further away from the attachment point to the body than is the elbow. Or I could say the elbow is distal to the shoulder. The elbow is further away from the attachment point to the body than the shoulder. And then proximal would be the same thing. You know, so I could say the wrist is proximal to the fingers. So if I say the proximal end of the radius, for example, I would be talking about the elbow side. If I say the distal end of the radius, I'd be talking about down here. So we'll see a lot of tendons of the wrist, for example, emerge at the distal end of the radius and ulna down here, or at the wrist. So proximal is going to be closer to the attachment point. Of the body. And then distal would be further from attachment point. So again, it can be a comparative thing, like elbow is distal, more distal than the shoulder, or it can be in and of itself. We talk about the distal end of something, or the proximal end of something. So distal and proximal. What else? We're going to talk about dorsal and palmar, or plantar also. So dorsal and palmar / plantar. Dorsal, if we think of a whale or a fish, we think about a dorsal fin, so backside. So dorsal is going to be the backside of something. Palmar and plantar are going to be the palm side, or the bottom of the foot side. Palmar, these are mostly going to refer to a hand. So palmar, we have the palm side of the hand. Dorsal, we have the dorsal side of the hand. So we'll say something like the majority of the tendons of the hand appear on the dorsal side. And if I say something like, you need to correct the shape on the dorsal side of your foot, then you know what I'm talking about. Or the dorsal side of your hand looks good, but the palmar side of your other hand has some issues with the values. So palm side, dorsal side. And for the foot, it's the same. The dorsal side is going to be the top here. Plantar is going to be the bottom side, where your foot is planted on the ground. Dorsal and palmar. One last grouping we're going to look at, and then we'll be all done with our terms here, is anterior and posterior. Anterior side is going to refer to the front side of something. Posterior is going to refer to the back side of something. So for example, our pectoralis muscles and our belly button are on the anterior side of our torso, whereas our shoulder blades are on the posterior side of our torso. We can also talk about the anterior side of the humerus has the bicep. The posterior side has the tricep. It becomes a little bit more confusing when we go down to the forearm because we have that radius bone where things start to rotate everywhere. But everything else is, pretty confidently front side or back side, anterior side or posterior side. We have anterior side of our thigh, we have a posterior side of our thigh. The posterior side of our thigh has our hamstring muscles. The anterior side has a set called the vastus muscles, which are a counterpoint to the hamstring muscles. So we're always going to have an anterior side and a posterior side. And what we'll start to notice, and we'll talk about a lot next week, is how for each muscle or set of muscles on the anterior side, we're going to have an opposing and equalizing set of muscles on the posterior side. So the anterior side will always have a matching muscle group on the posterior side as well. But we need to keep in mind which side we're talking about, anterior or posterior. So anterior is going to be front side, posterior is going to be back side. So that's all the lecture we have today for the anatomy, and now we'll actually do our Bridgman demonstration. So we'll need our Bridgman book, and we'll need a gel pen and some white paper.